Hi everyone, in this video I want to look at dev containers and GitHub Codespaces as a way to simplify the development experience. Because if I think about it today, when I'm a developer today and I want to contribute to some project, write some program, it can get very complicated. If I think about I have my local machine, well, to contribute to a project, I might need various types of tooling, various packages, various libraries, SDKs, compilers. The list goes on. And of course, my IDE, my integrated development environment, where I actually go and write my code. And if you look today at a lot of repositories, they might have this really long README file at the start about all the stuff you have to go and get set up before you can contribute. Now imagine I want to be able to contribute to many different projects. Maybe I just want to jump into a project quick. I've been using the tool. I found a problem or I've got some enhancement I want to contribute. And it has this massive list of requirements that maybe even conflict with the things that I actually have on my machine. So over time, my local dev machine would just get polluted. It would get very messy, which is not a state I want to be in. And if you think about that logically, setting up for hours or days a whole bunch of requirements to contribute to something is very defeating. And this idea of possible collisions and complexity is what we solved with containers for the hosting and execution of programs. If you think about in the container world, what we did is you can imagine the idea that, hey, there's some environment where I would do my testing. So maybe I have my dev environment. And one of the challenges before is, hey, the environment I'm developing in, that I'm testing in, didn't match the production environment. So you would say, hey, it worked in testing, it doesn't work in production. And so the solution to this was you would create these ideas of having a container image. And the container image was really based on lots of layers that I would prescriptively describe via my Docker file. So it would build on a certain operating system, and then I could apply various libraries, I could add various packages, and then I would have various tools, I would have my app, and that would be my container image. And then I would take that container image and I would execute it inside a container, which would sandbox various processes, network elements of it. And so because this dev image contained everything very prescriptively, when it came time to move to production, I would use that same image. So now I'm in prod, and I would just have another container instance that would use the same image. So we solved the complexity and the problems by having these container images that, again, were built on other container images. So you could tweak them, get the exact components you wanted, but it ensured consistency because now the environment was completely contained within this image. So it was very prescriptive, and it solved the problem of, hey, worked here, didn't work here, or just having tens of pages of deployment. This solved that problem. And so now if you think about where we are with development, we want to take the exact same idea. What we want is the development environment as code. So we want to be able to define, this is the development environment required to contribute to this project. And dev containers is the solution to this. And it's going to work in a very, very similar manner. You can imagine what we're going to have on the local machine absolutely is going to be a container. And we're going to have a way to define what is the image that we're going to develop within. So I can think about, well, okay, just like we had an image here for the execution of the program, what I can now define is an image that contains the development environments. This is going to be our dev image. And just like any other container, well, there's going to be a layer that's the OS and updates to the OS. There'll be layers that are the libraries, the packages, the SDKs, the tooling, all those other things. And via dev containers, we will run that image on our machine. And then the key point here is our local IDE will connect into this for the actual debugging and the testing and the running of the processes. This means I don't need any of these things locally installed on my box anymore. All I require is my IDE and obviously the ability to host the container. So on Windows, for example, I'm going to have Docker Desktop, which can then host the container that's going to have our complete dev environment in it. And obviously, I could also have different dev containers for each of my various projects. So it's going to be really easy now to switch between, hey, on one of them, I'm running Node, I need this version of this library and this package. Oh, a different project, I load in a different image. And I connect my IDE to that one for this other project. So the easiest way to actually understand this, I think, is if we actually just jump over to a second to VS Code, we can go and take a look at what this actually looks like. So this is a little Node JS project. And I'm on Windows. And one of the things we can quickly see is I don't have Node installed on my local machine. If I try and run it, I have no way of executing this. So we're going to use dev containers. Now, firstly, before I go any further, there are extensions for this. So if I go and look at my extensions installed, in this case, I'm in VS Code, we can see I have the dev containers extension installed. And it will actually recommend this extension as well if it sees I have a certain definition for this. Now, if I go and look at my project, what you're going to see is I have this .dev container folder and then a devcontainer.json file. So this file is describing everything about the environment and that container I want to use. So just super quick, when I think about this all up, my project that I have, so on my local dev machine, for example, I'm going to have the various files that make up my project. And in one of these files, I have this dev container.json. And that dev container.json file is what describes multiple elements. What is the image I want to use within that container? And then what does the container look like that's actually then going to host that environment? And what else other things should it be setting up in terms of my IDE? So this one file is huge in terms of the definition of what that whole environment will be. Okay, so if we jump back over again, so we can see in my case, the first thing I specify is the image. Now it's coming from the Microsoft Container Registry, Dev Containers Universal. This is the kitchen sink of templates that I could use. And we'll go into more detail on that in a second. I'll tell it the number of CPUs I want. 4 is very common to be able to do something useful. There's other configurations, what files I want open by default, any other GitHub Copilot settings I have here as part of the VS Code. Port forwarding is really important because obviously processes I execute are going to be running in that dev container. But I want those processes to actually be usable from my machine. So one of the things we absolutely can do here is from within my container, there are certain ports that I can forward into my operating system. So it'll be available via localhost, so I can then go and actually leverage those things. And there's also, so I showed you one template. If we go and look at the documentation for development containers, this is a great site. Just go to containers.dev and check this out. But it has a list of available templates. So there's all these different templates that I can use as part of this. Now, an important point today when I look at all these fantastic different images that I can use is they are Linux based. So when we talk about this, an important point is it is Linux, which is why, for example, on my Windows machine, I have Docker Desktop to host the container because I'm essentially running it in a Windows subsystem for Linux to give me a Linux kernel on which the container can run. So all of those templates you're seeing, they are built on top of Linux today. Then if we go and look at all of the different configurations we can do, this is a description of what I can put in that Docker file. And you'll notice in mine, I'm specifying an image, but I could also just specify a Docker file. So I could bring in a Docker file instead to build the environment I want. And there's lots of other configurations I can specify as part of that. But you'll see things like forwarded ports, the port attributes, and many other items. So I recommend you definitely go and look into the detail of that. But the upshot is, so right here, you can see it's not working, but I have a dev container file. Now I have installed that extension. Execute that. Just going to select my local folder. It's now just reopening it, but now within a container that it's going to launch on my machine. And if I look at Docker Desktop, as it's doing this, we can see, well, there's the container instance. It's giving it a nice name, Romantic Edison. But I can see that container. And we can also see the images it has pulled down. So it's pulled down that universal image that I specified as part of my dev container. And if I go and look inside this container instance and look at the binds, one of the interesting things you'll see here is the project is local on my file system, and it's mapping it through to a bind inside the container at Workspaces dev container sample. So it's sharing the file system through to the environment. So now if I go and look, so you see I've got the same files available. I'm in this Workspaces dev container sample, but now if I try to run it, these are all running within that particular process. It's saying, hey, port 3000 is forwarded. I can open it up. And there's the little app I wrote. It's the game of life. So there's rules about if a cell survives or maintains or gets created or gets killed. So you can see it's running. The process is running inside the container. But as we talked about, it's forwarding the port. So there's a process running inside this container, but it's exposing 3000 from the container onto my local host 3000, so I can easily go and integrate and test and debug and all of the other things I might want to actually do within there. And that's really the huge power of what this thing is doing. My local machine now has to know nothing about all of those different components and libraries and SDKs. I just have a basic IDE, VS Code, on my machine. And everything about the environment required to do the development is defined prescriptively as part of that container image. And then if you think about that file, it tells exactly what I need as part of that. So I just have my devcontainer.json, and it's telling it everything I need. So the image I need, how many CPUs I need for the environment to actually participate within it. And I can stop that, and it would stop the project. Now, it is Linux only today. So let's say I wanted Windows to be able to contribute. Well, in that case, I'd probably be using something like the Microsoft DevBox. Microsoft DevBox is the complete development environment hosted in the cloud. So that would be another option to use that. So this is phenomenal. The ability to use these dev containers takes a lot of the pressure off of my local machine. And also it massively simplifies the development environment because now I don't have to go and set a whole bunch of stuff up. I just define it maybe as the creator of the project for all of the things I need. Keeps my machine very clean. I don't have to worry about anything anymore. But the container is still running on my machine. So I have to make sure I have sufficient resources to be able to actually go and run that container. It has to go and pull the image down to my machine. So I'm going to store the images. There's a certain amount of overhead and resources to do that. So this is where GitHub Codespaces comes in. You can really think of GitHub Codespaces as dev containers running in the cloud, which is really exactly what it is. It also means this Linux requirement still applies. So it's all going to be Linux-based. So once again, Microsoft DevBox would be the solution. So now I can think about this as with the GitHub Codespaces, well, we have the good old cloud. So this is my GitHub Codespaces environment. And what it's going to do is it's going to create a virtual machine first. Because remember, the virtual machine has the kernel. And in the cloud, I typically don't want to share kernels with other tenants. So I'm going to get my own VM. And then inside the VM, then it goes ahead and creates the container. So it's a ratio of kind of 1-to-1 here. There's a container in the VM. And the VM isn't really doing much at all. I'm not really interacting with the VM. It's there purely to give me kernel mode isolation. It runs a few processes to check on the container, but it's not doing very much at all. So I'm getting this Linux. I'll stress the fact that it is a Linux virtual machine. And that's going to host this container. And so once again, when we had this idea of, well, there was this image, we'll have exactly the same idea again. We'll have the image we specify. Now, it has a default. I don't actually have to specify an image. So if I don't specify one, it will use the universal one that I actually named within my file. But I could specify other ones, and that's going to get pulled into and execute within there. I'm also going to specify as part of the configuration the number of vcores I actually want for my particular virtual machine. So I do specify a certain number of vcores, which comes into how this is billed and consumed later on. And then exactly the same as what we had before, our IDE before connected to that local container. Well, now what it's going to do is our IDE is going to connect to this one. So it's just changing and connecting to a different process. Now, what this means is there aren't really any local resources consumed anymore. So it gets up and running super, super fast. If you think about the environment GitHub Codespaces is using, the speed of which it can go and pull down the images is super fast. So it's going to get up and running really, really quickly. And the other benefit here is I could actually run this entire code space within the browser. So it has a VS Code browser version, which I'll show you in a second. So I don't even have to use a local IDE. I could actually connect directly from the web and run and execute all of this stuff. There are some other capabilities added. For example, it has automatic integration with GitHub Secrets. So it's going to make that a lot easier to use. But this is probably easier to just go and see this thing. So if we jump over again, so we'll kill this off for a second. And this is my sample project. So this is the one that we've been using and that I'm sort of coding from locally. And normally we have this idea of code, but you'll see there's also now code spaces. Now I've gone ahead and created this already. So I already have the code space. We can go ahead and create it. And you'll notice they give them the same fun names based on the dev container weird naming. Cautious dollop. It's not ideal, but I see I have that in existence and I'm just going to select it. So that's now going to open the code space. Now it's currently not running, but it's going to quickly spin it up and That's it. So it's connecting to a VM it has available, it's isolated from anyone else, puts my dev container inside it. There's all my code, populated and available, and I'm ready to go. So I could try exactly the same thing. So if I try and run this thing, node server.js, server running at localhost, opening browser. Now you notice this time it's connecting through again, and there's my little program. So it's doing the same port forwarding type capabilities completely from the browser. So if I think about the same idea where we had the ports and we could forward the ports, we have exactly the same idea here. I can absolutely have various processes. So I have the processes all run within here. They might run off a certain port, and I can take that port. I can actually do a number of different things with it. So yes, I can absolutely take that port and I could forward it into my local box. So I can do private port forwarding. And that's a super useful thing. Hey, I just want to go and leverage this. But we'll see there are other options as well. But straight away, you'll see I've removed all of the mess from my local machine. So, hey, I'm using it in the browser. I can do all those great things. But I can still use VS Code as well. So if we jump back over for a second, I've stopped that there. I'm actually just going to go back to my repo. But we'll go over to VS Code. And I'm going to show you two other extensions. You can kind of see one of them's here already. So if I look at my extensions, I've also installed Remote Explorer and GitHub Codespaces. So Remote Explorer lets me go and connect to remote machines and tunnel things like SSH. The GitHub Codespaces then adds to Remote Explorer's capabilities. So let me just pivot all the way out of this. Just go to my local one again. If I go to Remote Explorer where I have these installed, you'll notice it adds me the idea of GitHub Codespaces. I have signed in, so it's going to make me sign in with my GitHub handle. And now it's showing me what are the GitHub Codespaces I have. So there's my dev container sample. I'm going to hit the little connect to my Codespace. And now I've connected to that process running in the web. And it's going to look exactly the same as that browser. And once again, I could do exactly the same thing again. I can run my little project. It's running on localhost. I can open the browser. And sure enough, there's my little game of life. And I can stop that. But it's completely, to me, it seems like it's running locally. But all of the processes, all of the debugging, everything is running remotely in that other machine. And that's really the power behind that. It would also update the command palette. So I'm showing it via the little menu bar. And if I'm ever not seeing these Remote Explorer, I can always right click and you can select which ones you want to be showing. But also from the command palette, we'll see, hey, that Remote Explorer, I have a bunch of other options I can use to actually go and configure. So it's a really powerful set of extensions. Now, as I mentioned before, this image is running in its own virtual machine, so it has complete isolation from anything else. I can see I'm running in a container. So if I just go and look at my processes, we can see, sure enough, the parent is a Docker init. I can also see I'm in a container because I've got nothing else in my process namespace. Everything is really being blanked out here. If I was to look at my operating system at this point, if I look at my OS release, I'm running Ubuntu. So everything here is basically built on dev containers. So everything is running in this container. Now, and as I mentioned, I am using in this project, I specified specifically to use this universal image. But I didn't have to do that for the GitHub Codespaces. That is the default image anyway. So this default Linux universal is the one. And it really is, it's also called, again, the kitchen sink. 85, 90% of all the primary languages and core frameworks are supported. We can go and look at the manifest, and it gives a list of all of the various things that it has support for just built in. So JavaScript and its NPM package manager, Node.js runtimes, TypeScript, Python, the pip package manager, C#, C++, all of these various things are just available as part of this. And one of the interesting things about the GitHub Codespace is after a period of inactivity, it will pause, it will stop, and then I have to start it again. But it doesn't only have the content that's been committed to the repo. There is really this idea of a local file system that is maintained until it gets deleted. So 30 days of non-use, it will delete, and I would lose the stuff that hasn't been committed to my repo. But what it's really doing, if you think about it's the image that's being pulled into your environment, what it's also doing, if you think of Azure, so we have Azure over here, and we have really a managed storage account that you don't see, but within there, it's creating a blob. And the blob, it's being mounted on top of this as a read-write layer. So the temporary files I'm working with in my project, so as I look in my dev environment, so here I'm in my GitHub Codespace, I might be editing a file that I've not committed yet, and then I go away and it stops, and then I come back to it and it restarts. I wouldn't have lost those local files as long as it's within 30 days. And as soon as I connect to it again, that 30-day resets. So I get another 30 days or until I manually delete it. So those are being maintained in a blob, and it just gets pulled in as that writable layer on top of all of the image. Now, the other thing I did want to talk about is we see this idea of ports, and we saw this. The application's port 3000 is being forwarded to my local machine 3000. And you'll see this idea of visibility is private. But I can change this. I can right-click on it and change the port visibility to public. Now, if I was part of a GitHub organization, I would also have an organizational version. So if I change this to public, and then I'll start my app again. If I open in browser, this URL I could now publicly leverage because I changed the forwarding to public, so I could go and share this. If I was part of a GitHub organization and I changed it to the org level, well, then anyone in my org would be able to use it based on the GitHub. So as long as they're in the same GitHub org as myself, they would be able to use that. So for this port forwarding idea, I do have other choices. So I could also go ahead and I could just take that port and I could forward it to public. So it's just going to be some URL, or the GitHub org. So I'd have to be in the same GitHub organization, and then only they would be allowed to connect to it. So I have those choices. In terms of interacting with this, mainly the GitHub Codespaces, I'm using the web-based interface or VS Code, not the full Visual Studio. Full Visual Studio doesn't have the same client-server architecture as VS Code. You could also use SSH-based access, I guess, of a command line, but realistically, you're probably going to be using VS Code or the web-based interface to go and interact with the GitHub Codespaces. Now, an obvious question is going to be, well, how am I paying for this thing? You saw as part of my configuration, one of the key elements was this idea of number of CPUs. And 4 is going to be super common for most serious types of development. Maybe I get away with 2 for some more basic things, but 4 is going to be super common. And the way it works if I'm part of an organization, then my organization can just be billed and maybe I get a certain amount included, but they're going to pay for the hours I consume. If I'm an individual, then you get a certain amount included. So for the free accounts, you get 120 hours. For the pro, I get 180 hours. There's also then additional pricing beyond the included usage. And realize it's based on the number of cores. So in my case, hey, let's say I've got GitHub Pro in 180 hours, but 188 hours per core. So if I'm actually running a 4-core for an hour, well, that means my 180 becomes 45. So I could actually run it for 45 hours. Now, it does auto pause, and I can tweak that timing, and I can manually stop the GitHub Codespace to try and maximize that time. But the more cores I add to the environment, the quicker I'm going to consume the stuff that's included. And obviously for my organization, the more my organization will be spending when I just leave that up and running. But realize there's a lot of benefits in terms of what do I get out of? Yes, the dev containers is fantastic if I have the amount of resources on my machine. But imagine now the GitHub Codespaces, it takes all of the burden off my local machine, and it lets me go and contribute so quickly. Hey, I'm going looking at some GitHub repo. I want to contribute to it. They have the code spaces. I say, hey, I want to create a code space for this so I can contribute. I can get something tangible really, really quickly. I can go and get these prototypes stood up so quickly because I'm not worrying about, hey, using this environment to go and actually leverage these things. And so it takes that burden even further off of my local machine to go and use these technologies. And so that's the whole point of these environments. It's enabling me to define my development environment as code. So now multiple people working on my project get a consistency, even if I'm just using the local dev containers. But then I can think about shifting that up into the cloud. So now any project can define this same configuration for my devcontainer.json. And anyone can just really quickly come over to my project, spin up a code space for a couple of hours. Have all of the required components based on what I've defined as the author of that project in my devcontainer.json file. They contribute and they go away. That code space stops. They manually stop it. It times out and they go on to the next project. It makes it really easy to go and contribute with no overhead on my machine. So there you go. I hope that was useful. Till next video, take care.